Okay, fine. So this session is getting recorded, and the link of that also I'll share it to you in a while. Okay, so if you go to live, you will get the session link over here. All right. The link has stored it. Share link. Okay, there is the button, and yep. Okay. Okay, so the first question is, sir, can you please one show how to draw a twisted question on points? So let me go to Moodle to open the twisted question under lines. Okay, signing in. All right, let's go into our course, and you're interested in projection of points, the twisted questions. So this is projection of points and the twisted problem. Let me open up AutoCAD as well. Let me go for a quick preview. So the time limit given here is for 30 minutes. I think I forgot to remove the time limit, but anyway, 30 minutes are more than enough to solve the problem if you know how to solve it. AutoCAD is loading up. Meanwhile, let us check out what the question is. Okay, so ready template. Right. So the below data is given for points P and Q. Draw their orthographic projections and answer the questions that follow. So distance of P above HP and distance of P in front of VP is given. Same way, distance of Q above HP and distance of Q above Q behind VP has been given. So okay, so all these diagrams were for sections of solids, but because time was not enough, we were not able to solve section of solids. Anyway, so let us start solving this question. So first of all, we have to draw a horizontal line, and this horizontal line is the XY line. Next, we have to insert the legend. While inserting, explode should be on. Take the legend, keep it aside here, and yeah, of course this is XY line, and also those things you already know about. And so this is X and this is Y. All right, so now let us fix the point P first. Okay, in order to fix point P, first we'll have to turn on the nearest option over here, then take line command, yell enter. So first point we can take anywhere here. Fine. So the distance that is given to us, so what is the distance given? P above HP is 42 mm. So let's go back to AutoCAD, and from this XY line in upper direction 42 mm. And what is this point? He's telling 42 mm above HP. Above HP means this point is the front view, and front view is written as P dash. Next, let's see again, what is the distance given? Distance in front of VP. So if a point is in front of VP, then it will go below the XY line, correct? So from the XY line, take line command, click here, and in the bottom direction we have to take a distance of 60 mm. So let's take 60 mm. Again, let's go for a point, place it here, and this point is the top view of P, and top view is named without any dash. Okay, so front view, top view. So we know that this point P is in first quadrant. Okay, then let's go for Q point. The Q point is 62 above and 60 below, and also we have been given the distance between P and Q. So this information we need to use. Okay, so let's go with offset, O enter, and the distance here is 94 mm. So let's go with 94, and let's take offset of this line here. Okay, so offset of that line I've taken here. So this is the point, this is the projector line on which the next point, what is the next point? The point Q should be shown. Okay, so the point Q is 60 mm behind and 62 mm below. So from here take 62 below, and what is this point? The below distance will be visible in front view. So this is front view of Q. Then okay, so we have Q 60 mm behind. If the point is behind VP, its top view will appear above. Okay, so let me delete this line, take a fresh line from XY line, and the distance in upper direction is 60 mm. So let's go with 60 mm. This point here, okay, is the top view, and top view is written without any dash, right? So P dash Q dash is our front view and PQ is our top view. So lots of students had darkened these projector lines. Projector lines need not be darkened. We have to darken the final front view and final top views, correct? So these this is our final front view P dash Q dash, and this is our final top view PQ. Now the question is asking you to find a lot of things. So what are the things that it is asking you to find? The line is parallel to, line is parallel to none of these. Okay, line is parallel to none of these. That's what is the correct answer over here. Then the front view length it is asking. So what is the front view length over here? Front view length is P dash Q dash. So we'll have to come here to annotate, and in the dimensions we have to take aligned dimension, and we have to choose this. So this is our front view length, 140.2. 140.2 is our front view length, and top view length is PQ. Top view length is PQ. Let's take this, 152.45. 152.45 is the top view. Then he is asking apparent inclination of front view with XY. The front view P dash Q dash, apparent inclination means apparent inclination of the final front view. So this is the final front view itself. And the answer is 47.89. 47.89 is the angle. Then he is asking apparent inclination of top view. Top view is PQ, and its inclination, again we have to find it with XY line. So this is the angle of the top view, 51.93. And then we have to find the side view. How to find the side view? You already know about this side view. There is a slight twist in here. Okay, so because when we draw solids or planes, we always keep those objects in the first quadrant, whereas here point P is in first quadrant while point Q is in third quadrant. Fine. So the side view of P will come above XY on the right side, and the side view of Q will appear below XY on the right side. Okay, so this line is of course X1 Y1. Okay, this is the X1 Y1 line. Let me stretch it a little. Now let me take a point from, okay, so while taking this it's better if I turn off the nearest option. That will help me to easily select the endpoints. Okay, so this point has to go, okay, from here to here. Let's trim it off here to here, and from this point let's go up straight, and from this come straight over here. Okay, so this point here, what is this point? Because we are taking the projectors from front view and top view of P point, this point here is P double dash. This is the side view. In same way we need to take for Q. So from Q dash we need to take a straight line. From Q we need to take a line up to this point, and then we need to take a circle from here. Okay, so please ensure that the center is placed correctly, or else it will go wrong. Then we have to trim this part. We don't need this part of the circle. Okay, we are taking the top part. So yep, so this distance is luckily coming on the same point, and same point. So because it is coming on the same point, from that point we have to take a straight line over here. Fine. These two may not match all the time. Okay, these two will not match every time. Fine. Here we are just lucky that these distances happen to be the same. So 60 and 60 have matched up, and that's why we are getting it at the same point. So this point here is the side view of the next point, that is Q. So Q double dash. Okay, Q double dash. Okay, so this is the side view of Q. And if you join this point P double dash to Q double dash, so luckily it is exactly a vertical line. Okay, for this problem it is exactly a vertical line. It may not be vertical in all cases. Fine. So your point may be, the line may be inclined sometimes. Now he's asking us, what is he asking? He's asking us the side view length. So side view length is the distance between P dash Q dash. So I have to choose the dimension as aligned dimension, and I have to choose this. So the distance is 104. Okay, and finally is asking the true length. Now this is where maximum students are facing the problem. Fine. So most of the students have done the side view as well correctly, but it is the inclination, the true inclination, and the true length is where they are facing most of the problem. So let us see how to do this. So in order to see the true length, first we must make the front view or top view parallel to VP or HP. Okay, so in order to do that, let me draw a straight line from Q dash straight, and then I will take a circle from Q dash passing through P dash. Okay, so now this line, this is the front view. Now front view we are making it parallel to XY. Front view we are making it parallel to XY. Okay, so when front view becomes parallel to XY, this point that we get here, it is P dash, P1 dash it should be. So this is a temporary point. This is a temporary point. From this point, okay, line should be darkened as solids. Yeah, so these lines should be darkened, the front view and top view. Okay, let me increase the thickness a little so that you can see it clearly. Okay, so you can see I have darkened these two lines. These are the final front and top views. Okay, then from this point I need to draw a projector up to this line. Fine. Now the distance between them is very small. Okay, so from here I need to draw a projector to this point. So when I draw that projector, what do I get? I get the point P1. Now P1 is the top view of P1 dash. P1 is the top view of P1 dash. Fine. And from this point P1, I need to draw a line that is connecting here. Okay, and this is the true length. This line is the true length. Okay, so I have to take aligned length, take this measurement, 184.55. so this length is 184.55. you can see that I have taken around a little more than 10 minutes I have taken to solve it. I still have 17 minutes left with me. So that's what I was telling. If you know how to solve it, if you are clear with the concepts, you will be easily able to solve this problem. Okay, so let's check problem. I think check option, even though it's provided, it will not provide us with the marks or anything. You'll have to just finish this test in order to get the final marks. Okay, all right, so submit and finish. Submit, come on. Yeah, submitted, and you can see I'm getting full marks here. Okay, it's 100% marks I'm able to get. So this is how you need to solve it. Okay, so even though in this particular problem some lines were overlapping and you had to be careful with it a little. Okay, so lines were very near. Some of you will get more distance, some of you will get less distance, Some of you will get this side view as inclined line instead of just vertical. It all depends on what are the inputs given in the question. What are the inputs given in the question? Fine. So you need to follow the same process that I followed here. And of course, the video is recorded, so you can go back to the video anytime you want. I'll share the link in the group. Fine. Next, let's see what's the next question. Let's go back to our WhatsApp group. So this question is clear. Fine. How to draw twisted problem on points. Okay. Next, how to draw true shape of a problem. So which true shape are you talking about, Fatima? Can you clarify, please? Some students were asking me about conversions, true shape in the conversions, right? If you're asking about the same thing, you can stay silent. If you want me to do some other question, you can raise your hand or clarify it in the chat. Okay, so which question is this? Okay, this one doesn't have any true shape, so let me take a different question. If my sound is not audible at any point, please put it in the comments. Okay, continue large.py. Yeah, it's loaded up. Yeah, so in this particular problem we will have to build the side view as well. Okay, so let me keep it side by side to solve it out, right? I think, yeah, that is also present over here. Okay, so lucky for us, we already have the diagram drawn out. Okay, of course, this length is 100 mm. Okay, and here also we can see 100 mm. Very lucky. So we have got the front view, top view and side view built for us, and you know how to build this. It's very easy. The question was how to create the true shape. How to create the true shape. Fine. So I'm explaining the steps. Watch it carefully. So first I need to take O enter, T enter, O enter, T enter, and whichever face is inclined, so we have to take an offset of that. We have to take an offset of that at some convenient distance. Fine. So this is the true length itself. This is the true length, because here you can see this line is parallel to xy. Because this line is parallel to xy, the length of this will be true length itself. So whatever is the length of this particular edge, the same length will appear over here. Now coming to the true shape, what about these lines? These lines, are they the same length as they appear here? Yes, these lengths are also same, because you can see this is 30 and these lines are at 30 degrees on the left side. And when we see that object in the top view, they will appear exactly to be of same length. So this length is 30 itself, and same way we need 30 here in this direction. But one length which is not same in top view, you can see this length is the true length. This length is the true length, but when we see in the top view, this length is not the true length. This is not the true length. That's why we are drawing the true shape over here. Okay, so wherever true length is there, we have taken a parallel line, and then thickness of this will remain the same. So this same thickness, I'm taking a circle, you can see center point is here, it is passing through this point. So radius of this is now equal to the length of this edge. So same length we need to take and we need to mark from here. And here we need to draw a line perpendicular to this line. We need to draw a line perpendicular to this line. So for drawing perpendicular, there are two ways. So one simple way which we have discussed in the class is use rotate command. Okay, so select the object, give rotate command, then select a point, and after selecting a point, you can see I'm getting the rotation. Fine. So if I just click at this point, the same line will be moved to the next position. But I want a copy of this, so click on the option copy, and now click here. So when I click a copy, then an extra copy will be created at 90 degrees. Fine, because ortho option was on, it has directly taken the line at 90 degrees. But the length of this needs to stop over here itself. So let me trim this off. So this is the line. Okay, so the same line needs to come passing through this one as well. So we can just take O enter, T enter. So O enter, T enter, click here, and then click and click here. Okay, so this is our true shape. This is the true shape of the inclined face. And if you are asked to find the area or perimeter, first you will have to either convert it into polyline, or you can just go with hatch. Hatch command is the easier method. So give hatch command, H enter, and choose a pattern. So some pattern which you want to choose. ANSI 31 is the one we usually take. Then click here and press enter. So now hatch has been applied, and now you can measure the area very easily. Just type double A enter, double enter, and click on the hatch. You will get the areas and perimeters here. Okay, I see one student has raised his hand. You can unmute yourself and ask if you have any question. Okay, hand has been put down. So all right, so understood here? Any doubts here? So Afnan, you want me to repeat the true length? I'll share the video link. So this is the video link. I'm sharing it on your WhatsApp group. I've already shared it. You can go back to that link and you can watch whatever I've explained before. Okay, then so this question is clear, right? Then Vishal is asking, so how to find the area of wound and unwound involute? Okay, so this one is slightly difficult because you know the involutes are slightly tough. So let me explain to you that as well. So let me take the simplest of the involute. I'll go with the triangular involute. So 3 sides, edge method, and first edge length, let me take something like 20 mm. Okay, so this is a triangle of 20 mm edges, and I need to build an involute. Fine. So let me go with this, and I need to explode this. Explode command is X enter, and these are the lines which are now separated. Now EX is for extend. EX double enter, click on this, and then press shift and click on these 2 points, these 2 arcs. So they will go away. Next we need to draw a circle from this point. So take a circle, okay, from a end point and passing through this end point. Then again EX double enter, click on this edge, and then press shift and click here. I'm not taking a new command. Within extend, if you press shift, it will work like trim. Okay, I'm using that option. So again I have to draw it here, and it is passing through this center of this circle is here, and it is passing through this. Then I need to just trim this. Okay, so let me first extend this and then press shift and click on this. Okay, so this is my involute. So we will be asked to find the swept area. Okay, so how to find the swept area is the question. So let me explain to you one by one. So first let me just go ahead and apply the properties. So this is our involute, so it should be dark, and this is our cross section. So cross section should also be dark. In order to darken that, first we'll have to break this. First we will have to break these lines, okay, so that we get this triangle separate, and then darken the triangle. So the swept area is this area. The area outside of the triangle is the swept area. Now for finding this, we will have to use a workaround, because hatch command, even if it works here, hatch command will work, but when we try to take area, double enter, it will not accept it, and it will give an error, because it will say that the object does not have an area. So what to do with this? Now the workaround is copy this aside, okay, and copy this entire thing aside. Okay, so this and this we need to take them aside. Okay, then put hatches on this area and put separate hatch on this area. Don't put the same hatch. When you select, both of them should be separate. So in one command I'm creating this hatch, in a different command, new command, I'm creating this hatch. Now take double enter, click on this. Now this will provide the area and perimeter. Okay, this will provide the area and perimeter. So note this down, and then again give double enter. This time take this area. Okay, so whatever two areas you are getting, one area is here 6,000 something and the second area is here. Okay, so we have to subtract these two areas in order to get our answer. We have to subtract these two areas in order to get our answer, because when the string is rolling on this, the string will never go inside the triangle. The string will always stay outside. Okay, so only the outer area we need to find. Okay, hatch command will work here itself, but that hatch will not be able to provide you area and perimeter, and that's the problem with AutoCAD. Fine, some commands are incomplete in AutoCAD, they will not function properly. So this is the workaround which you can use in order to find the area of the involute. Okay, so hope your question is solved. Area of the wound and unwound. So what about wound? This is unwinding. That's happening. If you want to wind it, then some length will be given to you. So let's say we are being given 55. Okay, so 55 length will appear over here. Now from this 55, from this length 55, we have to go inside. So this is the length 55. Now we have to wind it from outside. So take a circle from this point passing through this. We have to trim it up to this point. So TR double enter, trim this up to here. Then again circle this point passing through here. Okay, again trim this circle. Next it will roll over this point. So that is the point we need to select, and then again trim it. Okay, so this is our involute. This is our involute for winding. The outer one is for unwinding and the inner one is for winding. Okay, so once you have done that, once again you need to build the hatch. H, enter, click here. So the hatch has appeared at correct place, but I don't know whether it will be able to provide area or not. Let us check it. Double enter, click on this. Okay, so it has provided the area directly. Okay, so this is how you can measure the area for winding of involute. Okay, so Vishal, I hope I have solved your problem. If there is any other doubt, you can put one more message. Next question is from Shravan Chiluka. Okay, so can you upload all the problem solutions on your YouTube channel? Okay, so actually time is not enough now. I spent a lot of time in creating those problems. Okay, so I didn't get enough time to create solutions to record solutions to all those problems. So maybe this time it will be difficult for me to upload all of them, but I'll definitely try to upload one or two questions which you ask me. Okay, so if you have any such thing, you can just let me know, and I'll definitely add whatever questions are possible from my end. Then okay, Fatima is asking 3D to 2D, sir. Okay, so I think this is in relation to the same question which is asked earlier, how to draw the true shape. So true shape I have shown for 3D to 2D. Okay, so do you want me to solve one more 3D to 2D with true shape? Yes or no? Please let me know. Raise your hands if you want me to solve this again. One more problem if you want me to solve, please raise your hand. So shall we go with this problem? Okay, I see a few raised hands. So let's go ahead and solve this particular problem. Okay, so this one will again solve for the true shape. So before going for true shape, we first need to find the front view and top view. Side view I'm not going to build, because I think the front view and top view will be enough to create the true shape. So let me go with the horizontal line, and in order to start drawing this, I will disable the nearest option and I'll start somewhere here. So what is the height? Height is C. Now C value, again I have to take it from the question. So let's go back to our Moodle course, and what problem is this? This is the 7th one, right? No, it's the 6th one. So we'll have to go for the 6th problem. Continue, right? Oh, yeah, continue last preview. Okay, I think we opened the wrong one. I think it is 7th one. Oh? No, it's not even the 7th one. Is it 5th one? Yeah, that is the 5th one. So 5th question is over here. Let's take the values of A, B and C. So these are the values. Let me copy paste these values over here. Okay, so A value is 75, B value is 65, C value is 50. So these values we will take and we will build a diagram. So let me make it full screen so that more space is available. So line command, from here the length is C. The C length here you can see it's 50, and then from this point horizontal value is A length is 75, and at this point it is 12. Okay, so let me just put quick dimensions. This length is 50, this length is 75, this length is 12. Okay, so these lengths I have taken from here, and then let me join this point with this point. Okay, so this gives us the three faces M, E and D. So we need to do subdivisions. Subdivisions, you can see they are at 25 and 25 from both ends. So offset 25, 25 from here to here, and 25 from here to here. Now we need to use trim command, tr double enter, to remove this. Press shift and click to extend it. Okay, and all these edges are visible edges. Match properties, take solid properties and apply on all these. Okay, next we will see the face P, which is triangular here in front view. Okay, so for that we know the distance, we know the horizontal distance is 12. So O enter, 12 enter. So take horizontal this. Let me extend it here. And from this point, from this end point, so for end point let me disable the nearest option. Click here, and from there the height, you know, it is 16. So from there let's take height 16 mm, and then take a horizontal line, Okay, trim this extra line which is extending on that side, and remove this line as well. We don't have any edge over there, and of course these two edges are visible, so they need to be made dark. So this gives us our front view. There is one hidden edge over here that is at 12 mm below that top line. So let me take a line from this point in downward direction, distance 12, and then a horizontal line, and then I will trim this extra line down. Then okay, I need to make it as hidden edge. This edge will be hidden. So this is my front view, and now let me quickly go ahead and make the top view. So top view, first line I can take at any place. These two are projector lines. Then from here the length is B value is 65. So let me complete this box. So this is the outer box. Okay, it's the outer box. Then there is a cut here, and that cut is at 25 mm distance, and 25 we have taken already here, and so 25 we have taken here, and the inner length here is 12. So offset of 12. Let me take here, remove these lines, they will go away. So now we have got most of this face. Now we need to build the face R and we need to build the face F. Now for F, the distance given here is 15 from top edge. So offset 15 from this, and then from there we have the length 25. We have the length 25. So again offset, go enter 25, click here. These two are over. Next we have to take projector lines from this point and projector line from this end point. Okay, so that will define, which face will it define? It will define the face F. This will define the face F. So F face also we need to make it dark. So all these edges are dark. These two are projector lines. You can delete it if it is disturbing you. Yeah. So we got the face F. Now we need to build the face R. For R, 22, 22 on both the sides. So offset 22, 22 from this side and 22 from this side. Then we have to take from the end point of this hidden edge. From the end point of this hidden edge, we need to take a line, and then we need to trim this off. Match properties over here. Projector line, you can delete it if it is confusing you. Okay, so this gives us the top view. This completes our top view. Now we need to build the side view. Now we need to build the side view. We don't need it, so let's focus on true shape. Let's focus on true shape. So for true shape, first we need to take O enter, T enter. Now we want to draw the true shape of this inclined edge, so we have to take that inclined edge at some convenient length. Then we need to draw a line perpendicular to this. So for perpendicular line, I told you the command. We will use rotate command and select the point, and then before clicking or before giving the angle, we will select copy. So create a copy and click here. Now this line is perpendicular to this line, so this line we will be using for the edges, these edges. Okay, so whatever these lengths are there, we need to take from this edge over here. Okay, so whatever is the length from this point to this point, this length we need to take it from here. Okay, then the other side, this length is also equal to this length. Okay, so let's take O enter, T enter, O enter, T enter, offset through from this point, and one more offset through this passing from here. Okay, now you can see this cut. This cut is far away from the XY line. This cut is far away from XY line. Hence the cut should be away from this. Okay, and we know the distance. So take this distance. What is this distance? This distance is 12 mm. This distance is 12 mm. So let's take an offset here. O enter, 12 enter, from this edge 12, and then we need this distance and this distance. But these are not true lengths. These are not true lengths, while this one is a true length. So you have to take O enter, T enter of this line. You can see I'm getting a parallel line to that, and it should pass through this. Okay, and also, okay, 1 minute, not this, we are doing the cut, right? We are doing the cut, and the cut points are here. End points of the cut are at these 2 points. Okay, so be careful. We need to take from this point. Okay, so do O enter, T enter, click here, this point and this point. Then trim it like this. Okay, now we just have this face left. Okay, this face we need to again take measurements from here. So whatever is this measurement, we need to take from this edge over here. So how to take that? I will use O enter. Okay, or else let's take line first. So whatever is this length, same length should be there from this edge. I'll take O enter, and whatever is this length, I can just click 2 points on this and I can take it. Or what you can do is you can just measure it. If you put a dimension, you will get this length, and this same length you need to take offset here. So O enter, 15 enter, take the offset. Okay, and from here to here, whatever is this length, that length is again given in the 3D diagram as well. That length is 25. So again take O enter, 25 enter, this here. So these two lengths we have taken here. Now all we have to do is O enter, T enter, offset through. So this line passing through this point, this line passing through this point. This is the shape we are interested in. So select all these edges, TR enter, remove all these extra points. Okay, so this is the shape over here, and you might as well draw this line. Here you will get this edge, over here like this, but we need not draw that edge because we are drawing the true shape of this face. Okay, we are drawing the true shape of this particular face, so that's what we need to show here. There is one more cut here, right? So there is one more cut here, that also we need to show. So 22, 22, these are true lengths, so we can just take it directly. O enter, 22 enter, from here 22 and from here 22, and O enter, T enter of this you need to take from the end point of hidden edge. You need to take from end point of hidden edge, and then as usual you can just remove these lines. This line is also not existing, and this edge will be slightly different. This edge will be slightly different. We can just remove that off totally. Okay, so this is the true shape of our face. This is the true shape of our face. Now if we go with hatch option, H enter, you can put the hatch in here, and now for this hatch we can just measure the area. So double A, double enter, click on the hatch, and it will provide you the area. Okay, so it's a long problem, it's a very long problem, and only the best students, only the students who have done all the other problems very perfectly will be able to do this. Okay, so are there any other doubts? Let's see. Winding of circle involute. Okay, circle involute, it's going to take time, but winding I will anyway not ask about winding of circular involute. So you can just focus on unwinding of the circular involute, which is very simple. You have to take a length equal to the circumference and practice that. Right. Winding is way more tough, so I will not ask it in the exam also. Okay, you need not worry about that. Then he is asking 2D to 3D seventh problem, please. Let's see what the seventh problem is. The seventh problem, is it having ground edges? Yeah, this one you want. All right. So for understanding this, yeah, there is a hand raised. Sanya, what's your doubt? If you can unmute, please unmute, and you can ask the seventh problem over here. So I'll go ahead and solve the seventh problem. If you have any other things or anything, just put a message here or put a message in the Google Meet, or you can just unmute and ask your doubt. Right. So in order to understand this, okay, I think I've already solved this. In the template itself, I have provided the solution because many of the students were facing it difficult. I have provided the solution. Now, in order to understand this, if you want to understand this perfectly, just go to notes. In orthographic projection, go to notes, and in that I have provided links to the 3D parts. Okay. So if you just open this here, and if you see 3D interactive models, if you click on 3D interactive models, so this is where I have given the 3D models of all those parts. Okay, so 4 parts I've given the 3D links to it. Okay. If you click on this, it will open up in a new window. If you are opening it on your mobile, you need to have this OnShape app installed on your system, on your mobile. Okay. If you open it with your with this particular app, you will be able to interact with it. Okay. You can see this object is there, so you can roll and see it from different directions, how it appears from different directions. If you want the top view, you can just click on the top view. You will see what the top view looks like. If you want the front view, you can just click on the front view. You can see how it looks like. Okay. So this is how you can understand the problem. The solution I have already given here. This is exactly how you need to draw, and you also need to provide the axis lines. Okay. So axis lines you need to provide here. Remove all these projector lines and expand this a little, because axis lines will expand a little like this. Okay. Then you can use match properties. Okay, I'll have to put one more legend. Let's go with inserting one more legend. Export is on. Okay. So match properties. Yeah. Okay. So this is how you need to provide the access lines. Yes, ma'am. So finally we need these access lines over here. Okay, so let's go ahead and take access lines here. You can just click on these points, scale it a little. Scale command you can use to expand it a little. 1.5 or 2 you can use it, and then record. Okay, so these are the access lines which you need to place, and that should do. I hope this problem is clear. So 3D to 2D problem, 7th problem, we have done it. Then how to find wound and unwound. So this I have already solved. Okay, so I have already solved. If you had not joined when I was explaining, you can check out the YouTube video. And this is the YouTube video. If you didn't join in time, you can go back to the video and watch it over there. Okay, so those things are explained over there. So what is the paper pattern? Okay, so paper pattern will be very similar to what you had in the mid examinations. Okay, so I may ask a few objective questions or a few short answer type questions at the beginning. 4 to 5 short answer questions I will ask at the beginning, and all of those questions will be compulsory. You cannot have, you will not have any option in these small questions. Okay, all the questions you have to solve them. Then in part B, I'll provide you with 6 questions from 6 different topics. 6 different questions from 6 different topics, and you have to solve minimum 3 problems from them. Minimum 3 problems you have to solve from them. Okay, internet will not be available. It will be disconnected. You will not be allowed to use Moodle, or you will not be able to use your mobile phone. You will not even be able to use internet on your system. The complete systems have been formatted, so you will not even have any files prepared by your friends over there. Okay, so don't think that you will be able to somehow manage it, because you will not be able to transfer the files from one point to another. I will physically come to each and every student and check out whatever problems they have solved. Okay, so I hope I have cleared all your doubts that you had for this. If you have any other doubts, just raise your hands. If you are on Google Meet, raise your hands, and you can just post your question here in your WhatsApp group. I'll try to clear it. So it's almost about 50 minutes have passed till now. So if you don't have any more doubts, you can leave the session. If you have any doubts, you can just post the doubts over here. All the doubts have been explained in the YouTube video, the link to which I have shared here already. Okay, so before finishing, I just like to tell you to just like the video and share it as far as possible to increase its reach. It will just help me to expand my channel. So just open the YouTube link which I have shared, hit the like button, and if you have any questions later, if you get any questions, you can post them in the comments, or we are already always connected from this WhatsApp group. This way also you can ask any doubt that you may have. For any other problems, you can just click on these, and the 3D model of that will open up in a fresh tab. You can rotate and see it from different directions, how it appears, and that will give you enough idea about what it looks like from different directions. And you will also get an idea about whether any length in that particular view, are they true length or not. Right? If I select this face, for example, and if I go back to the isometric view, you can see that this face is inclined to HP. This face is inclined to HP. So in the top view, we will not get its true shape. In top view, we will not get its true shape. When you go to the front view, it will just appear like a straight line. It will just appear like a straight line. In the top view, even though full face is visible, it is not the true shape. It is not the true shape. So if you want to see the true shape, you have to see it normal to the face. Normal to the face. Okay. So this is the face that we are interested in. And while drawing, I had told you we will get one more edge over here. Okay. And the top edge over here will be cut over from that one. Right. So this edge and this edge and this edge also we will get when we are looking at its true shape. But these edges we will not draw. We need not draw these things, because in the question, if I ask, I will be asking only the true shape, area of the true shape, and true shape is the only this face which is highlighted right now. Only this face which is highlighted right now. So all these extra edges which are coming up over here, even though technically speaking they must appear, even these edges they should appear, but we are not interested in them. We are not interested in them because we are interested only in the true shape of this particular face. So everything else that is coming, we have to ignore it. Okay. So any other doubts? So most of the students have left. Those who are present, you can ask any doubts if you have any doubts. If you don't have any doubts, you can just leave the session. Once everyone has left the session, I will also close the session and finish this. Okay. What about index and date? So dates you can collect from Habib sir. You have signed in the register whenever you came to the lab, right? So you can take the register, and from the register you can collect all the dates, all the important dates you can collect from there. B section students have already done, and I think they have shared in the B section group as well. A section students, please, one of you, please, Yasir, please go to sir and collect all the dates. And when you complete your index, please share that index to all your friends so that they can also get all the dates. Okay. So in part A, from where we will have to study the short questions. So all these short questions, you will get it from the understand and remember level quizzes. Okay. If you prepare the understand and remember level quizzes properly, I think you will be able to answer these questions very easily. Okay. Part B is of execution part. Yes, of course. So part B, all the questions you have to solve in AutoCAD. Part B, all the questions you have to solve in AutoCAD. Okay. And part A questions, you can just write it in the answer script. Answer script will be provided to you, and one or two A4 sized papers will also be provided, on which you will be able to get the printouts. Printer will be arranged in the lab, and on those A4 size papers you can print the three problems that you are solving. Okay, any other doubts you have? Okay, if you don't have any doubt, you can leave the session. I'll stay back for 5 more minutes, and if you have any doubts, if you are posting any more questions, I'll solve them out, and once I'm done with those, I'll just close the session. Okay. So there was one person online, Mani Teja. Bro. Yes, bro. Okay. 77 views. Not bad. So if you have any more doubts, you can just post them. I'm stopping this in 5 minutes. Right then, goodbye. I think there are no more doubts left, so I'll just stop this